All right, now I'm recording. So sorry for any students who are watching this late. I forgot to record for the first couple minutes of class. All right, so exactly. A variable is anything that can change. So you can change things like your mood. Moods can change. Temperatures can change. Your happiness or sadness could change, right? So anything that can change can be measured or hopefully can be measured by a researcher. So that is what a variable is. So it's a key term to remember. A variable is essentially anything that does or can vary, that can change. So some things that we've talked about today in our examples is reaction time. So for me, my reaction time might be slower or faster than someone else's. So that's a variable. It's something that can change. Maybe if we did something like drink coffee or ate a good meal, maybe our reaction time could change that way too, right? So anything that can vary or change is a variable. All right, so theory. I've mentioned theory a couple times today. Most people actually use the term theory incorrectly, just in lay speaking about a theory. So here we've got the raptor saying, you say that's just a theory, and that's basically that you don't have an understanding of what scientists actually use as the word theory. So let's talk about that right now. So someone might say, well, that's just a theory in an argument, like to kind of dismiss an idea. Um, but what we actually use a theory as, or what a theory is a really broad set Sorry. Let me see if I can help this student who's still struggling to get into. All right, I'm back. Sorry about that. So this is one of the weaknesses of allowing students the option to create meetings, is that when other meetings get created, sometimes students get confused about which meeting to join into. But it's useful to have you have that feature so that outside of class, you can use this classroom essentially as a meeting place with your groups. So I definitely don't want to turn that feature off, but I also can't control the meetings that other people start, which is sometimes frustrating. All right. So a theory is a really broad set of ideas or a set of ideas that helps us explain things and can predict future observations. So we'll give a couple of specific actions. Um, All right, so a theory must be falsifiable. So by falsifiable, what I mean is that these ideas or set of ideas need to be able to be proved false if they are in fact false. So you might have a theory, for example, that the Earth is flat, or you might have a theory that explains a lot of data that explains that the Earth is round, right? So your theory needs to be able to be proved false. This was one problem with Freud's theories, is that they weren't actually falsifiable. So by falsifiable or able to be proved false, I mean that you should be able to collect data that then goes against your theory, if any exists. It has to be, your theory has to be stated in a way that would allow someone to find data that would uh, be able to prove it false. So, for example, a piece of data that might falsify the theory that the Earth is flat is being able to sail up in a weather balloon or a spaceship, right, and seeing that the Earth is in fact round. So that would be a piece of data that would then falsify the theory of the Earth being flat. Similarly, Freud's theories made predictions, suggested to people that certain behaviors were caused by certain unconscious motivations. And with that, with those motivations, he would often change when confronted with contradictory evidence, he would often contradict and change his theory based on what people were saying. As an example, he thought and talked about in his writings that smoking was an oral fixation, that you never got past that fixation on putting things in your mouth in childhood, and that continued into adulthood, that you didn't reach the next stages of development, that smoking a cigarette was an example of an oral fixation. So when someone pointed out to him that, hey, you smoke cigars, isn't this an example of an oral fixation? Aren't you actually at a earlier point in your development? He said, well, sometimes a cigar is just a cigar. So he kind of brushed away the evidence. So we can't do that if we're actually serious about our theories. If we are presented with contrary evidence, says, oh, well, I see these pieces about myself that suggest I'm at a further stage in development, but you're right, I am addicted to cigars or whatever. Well, there's something wrong there. I need to then adjust my theory to fit this new data in a way that explains all of it, that doesn't just dismiss this other evidence. So when you have evidence, for example, that the Earth is round because of things like shadows or actually pictures or seeing it yourself or other aspects that you could do to test that the Earth is round, once you get all those pieces of evidence, you need to adjust your thinking, adjust your theory to then fit the available data. So you can't just brush it aside. And so that's what we mean by falsifiable. A theory is these really broad sets of ideas that need to then be able to be proved false. Sorry for the troubles of getting students into the meeting, everybody. Hopefully we don't have these same kind of troubles in future weeks. It looks like maybe it's not actually working on some other devices. Is anybody else using an iPad to access the class? Or have you tried it all? Yep, I've used it on my phone. I'm using an Android though, so I've not ever tested Teams on an iPad, so I do wonder if maybe some of the features are just broken on iPad right now. I know there's been certain features that sometimes break when I'm so with these phones, are these Apple phones that you're using? Because I think that operating system should be more similar to an iPad. So for Marissa and Kelly. Okay. Well, then I would think that with the Apple operating system, Teams should be working then. So um, we'll figure out what's going on after class then, so that we don't spend more time with this. I am recording now, so William can definitely watch the recording after class. Okay, thank you, Brianna. I really appreciate that. As you can see, I'm not very good at multitasking, trying to do the lecture as well as do technical help at the same time. So I definitely appreciate that. And if you need to review anything that we're covering right now, definitely feel free to email me and I can get you caught up. That goes for anyone, really. If there's anything that we talk about during the class that you're confused with, that we cover, that you've read, as well as seen in the class meeting and it's still not really clicking for you, let me know and I can give you any support that you need there. All right, so with that, another good example of falsifiability comes with the idea, an older theory about spontaneous generation. So let's watch well, you can watch this little shorter clip from Bill Nye. I always like to put Bill Nye stuff in slides, but I'll just describe spontaneous generation. Spontaneous generation is a theory, and it was Aristotle's theory that matter was simply generated spontaneously from other nearby matter. And the idea came from things like when you have a grain store, when you have a storage of grain, what you can do is just sit it there and watch it. And after a while, suddenly you will see rats. And so Aristotle thought, well, that grain in that area generated rats, that they came from the grain, that they just appeared, so that they were spontaneously generated. So dead wood spawns or becomes mushrooms. So when there's dead wood lying around, suddenly mushrooms appear. So one day when you're out there, one day you'll see mushrooms. So that was the idea or the data that was behind spontaneous generation as a theory. It was a theory that any matter was simply generated from other nearby matter. So grain or on ships or grain in a field might spawn mice or rats. So remember, a theory, again, is this broad set of ideas that can explain or predict observations. So the observations in these cases were that wood or grain or things like that would suddenly seem to generate other matter, other life forms, the rats, the mushrooms, things like that. So it seemed, and the explanation was that other matter was just generated because of matter being nearby it. And so that is the broad set of ideas that describes spontaneous generation as a theory. So now we know that's not really the case, but it explained how life was observed for these people. So, and how things came to exist. So remember, we've got these broad sets of ideas. Those are our theories, but they need to be falsifiable. They need to be able to be proved false if they in fact are. So that's not saying that you assume that your theory is false. It just means that you have to be able to test it in a way that could show that it's false. So people figured out, well, we should test this theory of spontaneous generation. We should test and show if it is or is not true. So it was first falsified in 1668, basically showing that maggots do not spontaneously generate from rotting meat. So that was an idea, is that that's how maggots were created, just rotting meat all of a sudden will spontaneously generate maggots. So the experiment was, I'll put a piece of meat with no lid, and I'll put a piece of meat with a lid. Both these pieces of meat are going to rot, but the idea was that the one with no lid would generate the maggots, the one with a lid would not. And that did turn out to be true. Without the additional factors of other life forms coming and landing on the meat and laying eggs and things like that, the meat that was covered, even though it was rotting, did not generate the maggots. Another example is from Louis Pasteur. So you can see here, these are 200 years apart. So people still held on to this idea of spontaneous generation for a while, for a couple hundred years. So Louis Pasteur, what he did, it was boiled meat broth in this kind of swan neck flask. So boiled the broth in here. And so one was open to the air. So after boiling the broth to get rid of whatever contamination or life forms might exist in it, he let it be open to the air. And the other one, he sealed off the flask, so it was not open to the air. So when doing this, Pasteur found that the one that was sealed to the air did not grow new bacteria or new life. So the broth did not spontaneously generate new life when it did not have contact with the air. So why do you think it took more than 200 years, even after this point of Louis Pasteur? Not everybody believed it for a little while. So what do you think were some of the problems that led to that? To us, it seems, well, yeah, that's really clear. Of course, that's how life works, that this matter doesn't generate other matter spontaneously. So why do you think people held on to these ideas for over 200 years after these first tests?
I'm thinking maybe it could be because like back then things weren't as advanced as they are now. Like now, I know the internet's not always true, but you can just look things up, and if like a bunch of things say the same thing, then you're just gonna infer that that's what's true. It's just harder to get information and spread it than it's like was way harder to do that than it is now.
Yeah, that's definitely a big part of it. So part of it might have been, we've got some comments too that I'll read in addition to your comment, that it might have been some of a lack of education from people. And part of that does come from that same thing, that it was hard to disseminate scientific evidence, or it was hard to get it out there. So obviously not everybody could read books. Not everybody had access to scientific research or the research journals that were out. So yeah, getting that education to people, getting the knowledge of this experiment from 1668. Not everybody read that in their school. Even if they were in a field relevant to this, they might not have read about it. Change can be scary, yeah, for sure. So with that, they had this explanation since Aristotle. So for thousands of years before this. So it was something that they all thought was the case, right? That all the evidence seemed to point to spontaneous generation. So they didn't necessarily, so they might not have believed the experiment. And so Shay mentions that they might not have believed the experiment. And this is especially true because at this time, it was really hard to make good swan neck flasks or jars that were properly clean. So you could clean it with soap, could clean it with alcohol, but some types of bacteria might still survive those washing methods. So today we have really great ways to sterilize and kill literally all the kinds of bacteria and small organisms that might exist. But at this time, they didn't have those techniques. So if someone else tried this experiment but closed the lids too late, or tried this happened with Louis Pasteur's experiment. Other people tried to do this but didn't disinfect their broths well enough. It still did grow bacteria. So there was sometimes contrary evidence. But after a while, enough people saw that when you did disinfect things well enough, that the matter would not generate new matter. So this was actually part of the beginning of learning about bacteria for humans as well. Understanding that there are little tiny microscopic organisms and little tiny life forms like that. So part of it's the technology advances, part of it's that education, getting more people that data, seeing it happen more than one time. So we've got these two experiments, but if two other people don't get the same result, it can be really hard to say, well, yes, these two experiments were the right case. So that's a lot of what science does, is it has a theory that's making predictions. So you go and you test those predictions, see if it turns out to be true. But if a lot of times it doesn't seem to turn out to be true, you might say, well, maybe this theory isn't actually true. Maybe there's another explanation for all of this. So sometimes it might take more or better data, more or better methods. And so that's what a lot of these research methods are. So it takes a lot of times more than one experiment to falsify, because a theory is this really big, broad set of ideas. So you might show in one case this doesn't work, but it needs to be replicated. So it does take some time to actually do that falsification. So exactly, they didn't have as much control over variables back in these days. So here's an example from psychology, and we'll get to this in future chapters, but I'll give you just a brief explanation of Vygotsky's sociocultural theory. And this specific part of the theory is called the idea of the zone of proximal development. So again, we'll talk about this in more detail later on in the course, but I just want to give you an example of falsifying a psychology theory that's relevant today. So the broader sociocultural theory explains how people learn and has a really big emphasis on the culture that they grow up in. Basically, the idea that the culture gives people tools to survive within that culture. So, for example, my daughter's in school right now, and some of the main things she's learning are math and English, because in the culture here, people speak English most often, and they do math for a lot of statistics that are needed, banking, things like that. So those are tools. Vygotsky would call those, English and math, tools of this culture. So what we have is what we can do. So by the time she started school, my daughter could already count. So she could do that. Maybe with help, she could add small numbers, like maybe 2 plus 2 and things like that. But what she couldn't do, say, algebra. She couldn't do calculus. She couldn't add large numbers together. So now she's learning from a teacher how to do adding larger numbers. So right now she's working on adding 2-digit numbers like 38 plus 52. So she, with help, can do that. And pretty soon she'll be to a point where she can do that without help. So what she can do, that circle of what she can do, will expand as her capacities expand. And those things that she can do with help will also expand. So with the teacher's support, with a mentor's support, with a parent's support, with a friend's support, she'll be capable of other things. And so that's the basic idea of Vygotsky's sociocultural theory, is that the culture tries to provide us with these tools, and they do that within our zone of proximal development. Within that zone, this what we can do with help zone, that's kind of where we learn, where the process of learning is happening. It's things that we can't quite do just by ourselves. We need a little support, and then with that little support, we'll be able to do that by ourselves. So that's the theory, that we can learn with that support, that mentorship, practicing those things. And you've probably seen that in your own life. So that's the theory. So with that, I kind of just described this. So what might falsify this theory? What kind of evidence might show that people don't actually learn that way? Right now, it's still a theory in place. Like we still do think people learn this way. But what might show that this would be false? That people maybe don't have to learn through getting support from someone and like practicing it. Go for it, Brianna.
Maybe people with like a photographic memory. As they read something, they retain it instantly.
Yeah, so seeing someone with a ability different than you might generally expect, like photographic memory, yeah. With that one, then you would have to go back to the theory and say, okay, the photographic memory, it seems like they've now memorized everything on this page. Does that mean they now know it and have learned it, or is that just a picture in their head? So you'd have to go and say, does this falsify the theory? Can we get more evidence of this being the case? But yeah, that's a really good piece of evidence that might falsify the theory. So good idea. Any other ideas of what might falsify this theory? Yeah, that's another good idea. That if you've never showed your baby how to crawl, but they still started to do it, that they still started to crawl, that might falsify that people don't always have to have support from the people around them and their culture to learn something. Yeah, exactly. Another example, this one's kind of out there. But another example, what if someone just woke up one day and all of a sudden they could play piano at an expert level? So they'd never practiced it. So everyone has a different way of learning. So we've got a comment. I don't think the comments are recorded, so I'm going to kind of summarize it. Everyone has a different way of learning and has strengths in certain aspects and weaknesses in others, and some of that can be hereditary, for sure. I think the zone of proximal development does account for that, because if something's easier for you, then those things will come easier to you as you learn to do something. And you might have more strengths or have learned more in one area or one field than another. So you might be a really good writer, but you might not be able to do, say, math very well, as an example. So I think that can still fit into this zone of proximal development. But the other examples of crawling without being directly instructed, or that photographic memory, or just suddenly waking up one day and having some abilities that you were never directly taught, those kinds of examples might actually be able to falsify this theory. So if we see that people can learn that way, that they suddenly can just create some knowledge, that might falsify it. You might extend the theory to say, well, some people have instincts, like a baby maybe has the instincts to start to crawl, right? You might explain it that way. So you have to decide with these pieces of evidence, do we now have to adjust our theory? Do we make it a little broader? Do we throw the whole theory away and start anew? So that's kind of what scientists do, is they look at the theories that they have to explain and predict the data that they're getting. Once they get enough pieces of information that contradict with that theory, they have to decide, well, can we then modify this theory a little to then explain that new data, or do we have to throw it all away and have a new theory? So at different times throughout history, different theories have been completely replaced or just kind of evolved over time. So both of them are perfectly valid ways to do it, but you definitely have to be willing as a scientist to let that theory change in accordance with the data, which is an example of why Freud's wasn't actually falsifiable, because he wouldn't let his theory be modified. He was holding really strongly to it. He liked his ideas. And I get that. In testing my own hypotheses, it's hard when things don't work out the way you expect. But as scientists, we need to look at the data and be objective about it. So yeah, really great examples, everybody. So again, the theory is this broad set of ideas. You need to be able to prove that false. Then a hypothesis specifically, this is more of what people usually use the term theory This is more synonymous with how most people use the term theory. A hypothesis is a testable idea or a prediction, and we get them from theories. So our theory of the zone of proximal development, I might make a hypothesis, a guess, or a testable idea or prediction about the zone of proximal development that even though I don't speak Spanish, even though my wife doesn't speak Spanish, if my daughter starts a dual immersion Spanish class, maybe with the help, she would be able to learn Spanish. That might be a prediction that I would make or a hypothesis based on the theory of proximal development or the zone of proximal development. Sorry. Another hypothesis might be the example earlier today of the reaction times that maybe I've seen a lot better performance in sports from women than men. So I might expect or hypothesize or have a testable idea and predict that women would have faster reaction time than men. So I would use the available data, usually coming from a theory. My reaction time example is not really coming from a theory. But usually a theory will give us this explanation of phenomenons, and then we can make predictions based off of that. But as more and more of those hypotheses made by the theory turn out to be true, the theory gains more and more and more credibility. So if the theory can predict a whole lot of things accurately, if all the predictions made by the theory come out to be the case, then that theory has a lot more credibility. So you might have heard of theories in physics, for example. You might have heard, they all just left me, the ones I was going to use as an example. Well, if they come back to my mind, I'll come back to it. Yeah. All right. I still can't think of the theory of relativity. Yeah. So we've got the theory of relativity, and then there are now newer theories because the theory of relativity didn't necessarily explain everything. So there's theory of quantum mechanics, for example, string theory. And so each one of these theories kind of explains different aspects of physics in different ways and tries to explain pieces from some of the other theories as well. And so eventually, hopefully, physics, psychology, chemistry, everything will get better and better with their theories to explain and predict and describe all life and existence, essentially. It's kind of the idea behind science. So we can also have unfalsifiable hypotheses. So we want our hypotheses, we're testing them, right? We're testing if the women or the men have a faster reaction time. We're testing if my daughter can learn Spanish because that's being predicted by that theory. So let's say you have certain symptoms which could be the onset of a terrible disease. Your doctor says he'll run a test, but just a heads up, these tests always come back positive for that disease. So I'll reread that again. So you think, maybe you went on WebMD, you think that you're dying of a terrible disease. So you go to your doctor and you say, hey, I want the test for this disease. He says, okay, I can give you the test, but the test always comes back positive. Do you think that would be a very useful test? Yeah, exactly, right? No. We've got some comments coming in. No. It wouldn't be a very good example if you're getting a false positive. If you don't actually have that disease, you don't want that positive result. You want an accurate assessment, right? So with that, that test wouldn't be very valuable. Similarly, you've got to test your hypothesis in a way that it could come out one way or the other. Right? So if I try to teach my daughter Spanish based on the theory of the zone of proximal development, if I have her in a dual immersion class with a teacher teaching it in an appropriate way, she should be able to learn Spanish. But I'm testing this theory. It's also possible that she wouldn't be able to learn Spanish, right? That might be down to her, or it might be down to that's just not the way people actually learn. For the example of reaction time, I would have to test the females and males in the same way, in a way that they could score differently. if I tested them in a way that all of them scored like the exact same reaction time, that wouldn't be a valuable test. So you need to be able to test your hypothesis well, and that's when we come down to the proper way to do things like experiments and correlational studies, do good interviews. So with that, as we're trying to test things empirically, the first thing we need is an operational definition. What that is a definition that anybody can use, that other researchers can use to measure that same thing, and it's a measurable definition. So I'm measuring reaction time based on how many inches a ruler falls, or when I see the brain activation happen, like how many seconds it takes for that brain activation to happen. Then you also need to analyze data. You need to be able to do statistics, do the math, or at least know how to tell the computer to do the math. That's how I do my statistics. So how might we operationalize happiness? So how might we have a measurable definition? How could you test happiness in a way that you'd get like some sort of data? Any ideas how to operationalize happiness?
The what is it called? They have one for pain tolerance and emotions, like a smiley scale.
Yeah, really good example. It's actually one of my next pictures. So great idea. You can have a scale, some sort of measuring tool to operationalize it. You have faces that say this is how much pain you have. Are you grimacing in pain versus are you pretty happy? Another comment is serotonin is a chemical in the body that's related to your happiness. So you could measure the serotonin levels. And so that's exactly right. Those are two of some of the most common ways, actually, that we do measure happiness. So very good. So here we've got these scales. You might ask someone about their state of emotion. Are they depressed? Are they sad, content, happy, elated? Are these really on a scale like that? I'm not sure I would say they are opposites of each other, depressed versus elated. But then also the smiley scale. You might say, you know, I'm not feeling happy or I'm feeling very happy, and ask someone to self-report how they are feeling. This is an example of how we do get a sense of the neurochemicals in people's bodies. So as well as those neurochemicals, we can also look at their hormone levels. So with the mouth swab, you can get a person's hormone levels. That's a pretty good measure of what they're feeling at that moment. So you can get that swab, you can get it tested and see, well, at that time they had X levels of these hormones and X levels of these hormones. This is related to how happy they are. Not a good way to operationalize happiness might be this. So taking a measuring tape and measuring someone's smile. So that might not be the best way. Can you think of why that might not be the best way to measure happiness? Some problems with that measurement? Yeah, you can fake a smile. You can pretend to be happy. And just because your smile is big and wide doesn't necessarily mean that you actually are happy. It looks like we've got a couple hands as well. So it's opening up the participants slow, sorry. Oh, and the hands disappeared. I assume we're going to say the same thing then. So another difference between people is not only that you can fake a smile, but that people's mouths are literally just different sizes, right? So on average, the corners of people's lips are like right under their eyes, like right under their pupils when they're looking straight forward. But some people's smiles and mouths are a little bigger or a little smaller. So measuring might just tell you that this person genetically has a bigger smile, not necessarily that they're happier. So something like this scale using the faces or using words or checking hormone levels is a lot better. But you're absolutely right, Jonathan. You can fake your answer on the scale as well. You can pretend to be happy. That's actually called social desirability. I think we might have mentioned it in our last class, but you might respond to a scale when they're asking to report your opinions, your behavior in a way that's socially desirable. So that can definitely happen. There's ways that you can kind of you can't always completely get rid of the potential for social desirability, but if a scale is completely anonymous, so if I give everybody in the class this happiness scale, one of these two, and I let it be completely anonymous, like I won't know who it is. If I say, how was the lecture for you? Were you really happy about it or really sad about it? You're more likely to answer accurately if I'm not going to know who said what. Because if I knew who said what, you might be a little afraid that I might change your grade or not like you as much, right? So making it anonymous does help. There's also social desirability scales that you can use where it asks questions that people who want to appear socially desirable will often respond to in certain ways. So the statement, I sometimes lie, is probably pretty true of everyone. I sometimes lie to my kids that there's not vegetables in their smoothies, for example. So sometimes I lie, but someone who's trying to be socially desirable, when they see that question, will tend to say, no, I don't sometimes lie. And that in itself is probably a lie. So that's one way you can kind of get at it too, is making it anonymous, using scales like that. Adding additional measures. So if you do something like this scale, as well as check hormone levels at the same time, you'll get a better idea by using multiple methods of what someone's happiness is. So you bring up a really great problem there, Jonathan, about social desirability. All right, so now we have our data. We have our data on happiness or reaction time. Now we're going to analyze it. So you might use statistics. You probably will use statistics. And so you take the data from about these hypotheses and you test them. So I showed a distribution kind of like this earlier in class. So I drew my little picture of the averages for men and women on reaction time here. So you can compare those averages, right? You can also plot things into correlations. So what this might be, y-axis might be happiness level. So the higher up here, the happier you were, versus the lower down here, the more unhappy. And let's pretend X is reaction time. That over here is a very slow reaction time, and over here is a very fast reaction time. So you've got happy, sad, slow reaction time, fast reaction time. If we plotted out the data and saw this, we would say, oh, that is a positive correlation. It looks like the happy you are, it also seems to be, I'm going to say it differently than that because that sounded causal. It seems like people who are happier tend to have higher scores on reaction time, or people who have high reaction times also tend to be happier. That's what you would say based in this correlation. I don't think those would actually really be related, your happiness and your reaction time, but that is possible. And a big thing about correlations is that correlations are not causal. So my example here, the happiness and the reaction time, they're probably not actually caused by one another. Like your happiness probably doesn't change your reaction time. It might, I don't actually know. And your reaction time probably doesn't actually change your happiness unless you're trying to do something like win a game at a carnival. So if you've got a faster reaction time, you're probably more likely to win, and then you're probably more likely to be happy for winning that thing. But they're probably not generally causing each other. So two things can be related, but not causing one another. All right, we've got another comment here that I think is pretty relevant. You might feel happy under a state of being influenced by drugs, and that can even heighten certain hormones. So that can be changed to the way that you measure happiness too. So yeah, there might be ways that you could check for that. One, you could ask people if they've been using substances. Again, they could lie about that. So you see, when we're doing research with humans, it can be hard to get good data. Maybe some people who were happy because they were under the influence of drugs. Some people were happy because they really liked the appearance of the researcher. Maybe they thought it was a really attractive person doing the test with them, or say like the nurse or the doctor who is giving them a medicine. So there's a lot more variables that you have to try to account for in human research than you might have to account for when, say, measuring the chemical composition of I don't know why this is in my head, a steak or something. So you could check what chemicals were in a steak that you just cooked, how much salt, how much carbon, things like that. So there's a lot fewer confounding variables there, but when we're working with people, we do have all these problems, and that's why we need to do a really good job at testing and getting rid of those potential problems as best as we can. But really good criticisms or comments there. So with this, a key point of using these stats is to falsify your hypotheses. So we talked about that before, that a hypothesis is that prediction in any given case. So if we saw that both men and women scored the same on reaction time, if our hypothesis was that there would be a difference, that would then falsify our hypothesis. If both the means were exactly the same, the spreads were exactly the same, we would say, oh, actually, they're exactly the same on reaction time, or the same enough that we can't see any difference. And then you draw your conclusions. So after you've ran those stats, you say, has my hypothesis been supported? Do these results, do they falsify the original theory? Should we modify the original theory to absorb this new data? Can we trust these conclusions or methods? If we have a lot of participants who were using drugs in our study of happiness, can we trust those conclusions to apply to everybody? Well, probably not. If we did these studies with just white men in between the ages of 20 and 25, can we really trust those conclusions fit for everybody in the world? Well, I'd say probably not. So who can we generalize the findings to? That's a big part of that. If you've tested only students at Salt Lake Community College, would that apply to students who are in high schools in the Salt Lake area? Possibly. Would it apply to students who are at the University of Utah? I'd say probably. Would it apply to students at a university in India or China? I'd say probably not as likely, but it depends on what you're studying as well. Something like reaction time, probably. Something like their opinions on some topic, probably not. So then you evaluate those conclusions. You might replicate your study. We might do our reaction time study again. We might do our Louis Pasteur experiment again and see if we get the same result. We might have another researcher, or another researcher might be inspired by our work and then do a similar study that kind of adds to it or tweaks it in a little way, so we get a replication that way. Do we need to evaluate the theory? We usually send our work out for peer review. So when I try to publish a paper, it's read by other psychologists or other relevant scientists in the field I'm trying to publish in. So they will look over it and say, well, these methods weren't the best. What did you do to make sure not everybody was using drugs, for example? And then I would have to describe that in the paper, change things around. Meta-analyses are another good thing. It's basically taking all of the published studies that exist and redoing the stats of all of them together. So you might do your study on happiness and reaction time with 200 people. Someone else might have done the study with 50 people. Someone else might have done the study with 200 people as well. And then another person did it with 150. So if you could take all of that data and put it all together and run those stats again, you'd get an even better picture. And that's essentially what meta-analyses do. Use the data from multiple studies to try and find a better, clearer picture. All right, so this is a model of how you might do research to solve a problem. I'm an applied developmental scientist, so I try to solve problems that I see around development in some ways. For my work, it's usually to help people be more pro-social in life. So I see the problem of not as many people as I would like are as pro-social as I would like. So I do applied research. I look at the theories that are out there, the work that's already been done, experiments that have already been done. So I use those theories to in line with any other theory that I'm working with now. And I get out in the real world to actually work with people, maybe in the community or schools or other practitioners. I use appropriate research methods, whether it's experiments or things. I find my results and then I disseminate that to multiple audiences. So I tell the teachers, well, this did really well or this didn't do really well with your high school students. I put it into research papers so other people can put it into basic research or change policies or evaluate it in different ways. And so this is kind of a big cycle of using the information that we have and the theories that we have, testing things in new and different ways to try and solve problems. And eventually, hopefully, the problem gets solved. So you might say another problem that could be solved is essentially any social problem. So homelessness. Well, we've got a lot of research on maybe what causes homelessness, what things can be done to support homeless people, what things can be done to get rid of homelessness as a problem. So maybe we try 3 of those methods and we find, well, one of those 3 methods was the best. So we tell everybody and they make that method even better. Hopefully, eventually, in that kind of way, we could solve that problem. That would be great. So it's an example of how research is actually done to try and solve problems by psychologists. So there's a couple different types of research methods that we'll talk about. I feel like this would be a good time to take a quick break, grab a drink, and use the bathroom, and then come back. So let's actually take a quick break before we talk about descriptive, correlational, and experimental research in more detail. So let's be back at 3:51, and I'll see you in just a moment. All right, we are back. So hopefully everybody is jumping in and we can talk about types of research methods. So we've described these a little bit or like mentioned them in examples. So let's talk about what descriptive research is, correlational research, and experimental research in a little more detail. So descriptive research, it's kind of self-explanatory. It describes things. So we're describing phenomena. We're describing reaction time. We are describing happiness. We are describing heroism. It doesn't try to prove causation. And so by causation, it's not trying to prove that one thing causes another thing. It's just describing that, hey, I often see when a fire is hot, I often see that the things around it get warmer as well. I would describe that relationship. I wouldn't be trying to prove that the fire is the thing causing the other things to get hot. So some other examples that we use is doing observations. Correlation is not causation. So that is definitely a point that I will bring up quite a few times, especially as we go over some example correlation graphs. I'll show some examples that are a little silly of correlations that people thought were actually causal. So some example types of studies that we do are observation studies. So if you wanted to describe the behavior of college students, you might say go to a library or a common area at a university. Maybe not right now because there's hopefully fewer people there. Or you might go to, say, a coffee shop near a campus and observe and write down what students are doing. Another thing you can do is surveys. You can observe behavior, observe emotions through asking people to report their emotions. You can also get descriptive research by, say, asking teachers. Let's say this is a teacher reporting on their student. You might have a teacher report the student is happy in class or sad in class or engaged or not engaged, things like that. So you could get data from the student, you could get observational data from the teacher, you could do interviews. So you could sit one-on-one with a person and ask them questions. So you could ask them about their sports or their life or their development. For heroes, I do a lot of interviews with heroes right now. I also give them surveys. Essentially, I'm asking them about their childhood. What are things that they thought were important in their childhood and their adolescence and young adulthood, seeing if they can find common themes throughout their lives. So I'm trying to describe if they're the lives of heroes, essentially. Case studies are examples of, you've probably heard case study in reference to like a medical case study, like a really unusual problem or illness. So basically the show House, if you've ever seen that, that's kind of like all case studies. It's essentially a case is a unique phenomenon or unique group that you might study as a specific case, where you would do things like observing, doing surveys, finding out about what is special or unique about the specific case. So cases can be one individual, like let's say there's an individual who does suddenly wake up one day and can play piano without having ever seen a piano in their entire life. Never hearing music, something like that, just suddenly they can play piano perfectly. That might be a case that you would study. Another example that is actually a real one is there are areas where, I forget what the location was. I want to say Brazil, but that might be because I've been reading a lot of news relevant to Brazil recently. Let's just pretend it's Brazil. So there was a community in Brazil and there was a club that was started by young children. So I'm like 7 and younger, and they started their own club. They like organized their own clubhouse, organized their own meeting times, and like did things in the community that they wanted to do to either improve it or just have fun. So it was a pretty well organized club and a little surprising for the researchers when they learned about this. And so they did a case study of that group of children. So that whole group was the case, was the unique example that was showing something unusual. It could also be in medical terms, like an individual with a really unusual disease or something like that. Content analysis, that is when you would go through something written, whether it be a newspaper, a journal, like a personal journal someone would write, and look for specific content, analyzing the content of that written document. You can even do this with things like films to see if it has any kind of themes coming out of it. So correlational research is another type of research that looks at relationships between variables. So we could look at the relationship, or if there is a relationship, between happiness and reaction time. We could look to see if there's a relationship from the amount of water you drink a day to how well you sleep at night. We could look to see if there's a relationship, to see if there's any relation between heroism and early childhood experiences. So when we do a correlation and we get data and a statistic about it, your correlations will range from -1 to 0 to +1. So the positive and negative tells us the direction of the correlation, whether it's a positive correlation or a negative correlation. And that's not denoting like any value judgment on it. A positive correlation doesn't mean like a good correlation, and it just means the graph is going the positive direction, going up, and negative means it's going down. And then how close that number is to 1 tells us how strong that correlation is, or how strong that relationship between those variables are. So here's a couple examples. One interesting finding that was found, or that's been found many times, but I think the first study was in like the 70s, is there was a correlation, a positive correlation, a strong positive correlation between ice cream sales and violent crime. So I'm going to pretend this graph is that graph. So this is, let's say, ice cream sales per day, and this is number of violent crimes per day. So it was found that the more ice cream was sold was related to the most violent crimes reported. When there was about half as much ice cream sold, there was about half as many violent crimes. When there was very few ice creams sold in a day, there was very few violent crimes. So there was a positive correlation, a strong positive correlation between these variables. And so what the researchers originally reported in their paper was that there might be some relationship there. And relationship is a correlation. So when we're talking about a relationship, it's a correlation. So some people might say, well, did ice cream sales cause the crime, or did the crime cause the ice cream sales? What do you think? Or do you think there might have been some other cause leading to both of these things being related to another? So feel free to either raise your hand to make comments, or you can also put things in the chat box too. So do you think that the ice cream sales caused violent crime, or a rising crime caused more ice cream sales? Or is there some other cause? Sorry, Kelly, go ahead. My microphone was on mute.
I think it's just like correlation, not causation, but I think the crime went high because it was hotter in the summer. So summertime is usually when crime rates go higher because it's easier for people to break in. Most people are out of town. Like that's probably the reason why crime rate went up. It's just it's easier to rob or crime, or it's like crime is easier to do when it's hot and warm and you're not shivering in the cold.
Yeah, really good guess there. I see another hand from Brianna. Did you want to add to that, or have another idea of what could be causing these things?
Yeah, so I was just kind of thinking, like, if you have higher ice cream sales, you've got more people coming out to be able to report more crimes that they see. You've got more eyes on the situations that you otherwise wouldn't have with lower ice cream sales.
Yeah, so maybe more are being reported. But yeah, it really is all down and caused by the heat. like Kelly was saying. So I definitely think that could be a part of it, Brianna, with not exactly one causing the other still, but that because more people are out because of the heat is causing more people to go out and get ice cream. The heat is causing more people to do violent crime. So with that, more people are then reporting that violent crime at a higher rate. So yeah, all these things are not caused by the ice cream or the violent crime, right? Those things are caused by this third variable, which is the heat. So yeah, really good ideas there. Another example, and this was actually published as a causal example. It's kind of a sad one, a sad story, but it is a really relevant example of correlation not meaning causation. So in the, I forget when the article was published right now. It was near the Great Depression. It was a couple of years like after the Great Depression had started. What they found was that there was a strong correlation, a strong relationship between men's suicides and marriage rates. So they described this correlation basically as the marriage rates were declining, like years when there was fewer marriages, there tended to be more suicides by men. So this is what the article reported. It was a strong negative correlation, kind of like this one here. So the marriage rates, let's put that on this axis here. So when marriage rates were really low, the suicide rate was very high. So this here is suicide rate. When marriage rates were high, the suicide rates were very low. So there was a strong negative correlation here. And the researchers actually reported this as a causal relationship, that the fact that these men could not get married was leading them to suicide. Given our previous example of correlation not being causation, and knowing a little bit about the time frame of the Great Depression, do you think there could be a third variable here, maybe causing both of these things? I see Kelly's hand still up. Was that still up, or did you have an idea for this one, Kelly?
It was just still up, but I think I have an idea.
Yeah, go for it.
Like well, statistically, I'm pretty sure during that period of time, men more were looked at for suicidal rates. As that sounds sad, but it's a lot of psychology or a lot of textbooks in medical science really focus on men when it comes to medical prognosis. So it could be that it would seem higher in that case and scenario. That's what I think it could be.
Yeah, it could be that maybe these are just seeming to be related because they were measuring it more at that time. Yeah. So what it actually turned out to be, and future researchers actually showed this, so they published this paper that said that the decline of marriage rates was causing more men to commit suicide. Later researchers showed through other statistics, through more advanced statistics, that no, there was actually another variable in there that was more probably the cause of both of these things, and that was the decline in the economy around the time of the Great Depression. That essentially these men were losing their jobs, didn't have money, didn't feel that they could support someone who that they might get married to, and then also was leading to more suicides. So again, really sad story and example, but really relevant example of something that was published with a negative correlation that the researchers themselves took to be a causal relationship. So again, because we didn't do an experiment on this, we can't say for certain that that was the cause, but it looks like more probably the cause was the declining economy was leading to both the declining marriage rates and the increased suicide rate. So, and that's just another example to go to the point of correlation is not causation. So Remember that. That will definitely be on your final exam, that correlation does not mean causation, as well as on your first exam. It'll be there too. So here's another couple examples of positive and negative correlations, and we'll talk about the strength of correlations as well. So again, positive versus negative does not relate to any value judgment on the correlations, right? Not that. It's not saying a positive correlation is a good thing or a negative correlation is a bad thing. So here, the longer a lecture, the more you yawn is this correlation. And that's not a great example for correlations because this might be causal there. So you've got number of yawns higher and length of lecture longer, you might get more yawns, right? So that's a positive correlation. The closer it is to this middle line, the stronger that relationship, versus the further away, the weaker that relationship. So here, this is a slightly weaker relationship than this one. This is really close to one solid line. This is a little further off. There's more points further away from that middle line. Then this example here, you might be able to plot a correlation line, like whether it's positive or negative. To me, it looks like there might be more data going at about this angle, but it would be really weak because there's examples of people really far away from that middle line. So let's say a computer gave us a positive correlation here. Maybe it would be a positive correlation of R equals 0.02, which is a really weak correlation, 0.02. So with that, let's use the ice cream and violent crime. So this day, there was a lot of ice cream sold, but no violent crime. But this day, there was no ice cream sold, but a fairly high amount of violent crime. So that's an example of what these data points are marking. Here, there was a lot of ice cream sold and a lot of violent crime. Here, there was not a lot of ice cream sold and there was not a lot of violent crime this day. So that would be how you would plot these points on the data board. You'd look at, for July 12th, there was this much ice cream sold. For July 12th, there was this much violent crime. And you'd plot the point where those lines intersect. So you do that for every data point for an entire year or summer, and you get this whole mess of points, and you try to ask a computer to find you a line of best fit through that data. Then you look to see how much the spread of the data is around that line to see the strength of this correlation. So hopefully describing that in a couple different ways has helped you understand what these numbers mean. So something closer to 1. So this would probably be a correlation of positive 0.95. It's really close to a solid straight line. This one would probably be negative 0.7 something because it's a little more spread out from that line. So another example, this is a good example of there being a big spread of data around the more milk you drink and your test grade. So test grade is plotted here and the amount of milk drank. So if we did that for all the students in the class, we might see a graph kind of like this. Some students drink a lot of milk and do really good on the test. Some students drink no milk and still do really good on the test. Some students drink no milk and do really poorly on the test. Some students drink a lot of milk and do really well on the test. So the data is kind of all over the place, and this would suggest that there's no relationship between those variables. So there's a really low correlation or there is no correlation. So something like a 0.05 is a very low correlation. It's close to 0. A negative 0.05 would be a very low correlation. Something like a positive 0.95 is really close to 1, or a negative 0.95 is a really strong negative correlation. So we talked about this example. All right, so another example of correlational research is longitudinal research. So this is when you follow the same group over a long period of time. So you take a group of people when they're infants and you follow them to when they're 2, 6, 12, 20, 35. I don't know. I'm just making up ages here. But you follow them their entire life. That's the point. We don't have to have ages for every person there. This is actually from a longitudinal study of cognitive capacities of older adults. So it started following people, the same group of people from when they were 25 all the way to when they were 88. And so it was really assumed for a while that your cognitive capacities really started to decline around your 50s. But what we found through this and further longitudinal studies is that cognitive capacities really don't drop off until the early 80s, that people still have a lot of their inductive reasoning, perceptual speed, numeric ability, verbal memory, those all stay really consistent throughout most of adulthood. And so this is why longitudinal studies are good, because they can let us track data, see relationships. We can see the relationships of these scores compared to the age of people. And so longitudinal design would follow the same group over a long period of time. Now we get to experiments, and experiments are the thing that we use to determine cause. If A causes B, or B causes C, or if ice cream sales cause violent crime. We do experiments on these things, and they allow us to do that. This is an example of an experiment that we'll use as an example throughout the next couple slides. We have a hypothesis that studying in a quiet room or taking a test, let's do taking a test in a quiet room, will lead to better test scores than taking a test in a loud room. So here we've got a quiet room, no sounds going on. These students take a test, and half the class takes a test here in the room with a band playing. So it's really loud. So will that distracting environment affect things? You might have your hypothesis that it might be better in this group. So experiments, you must have two groups. You must be able to have control over some of the variables. At least one of the variables needs to be different between the two groups. So you're looking at two or more variables, and you're manipulating at least one variable. In this case, we're manipulating the noise level in the room. And then you check to see if that noise level change can make a change in behavior. So here it's a small picture. We would definitely want to test more people. It might just be that these 4 students are a little better at this subject than these 4 students, right? But if you tested 2,000 people on subjects that they had all learned about versus another 2,000 people, you'd have a lot better sense of if the distracting noise does make a change. So, but again, it's just a small picture to as an example. So the IV, or independent variable, is the variable you as the experimenter will change or manipulate. So I might manipulate the noise level in a room. I might manipulate the heat in a room. I might manipulate what kind of music is playing in a room. So maybe one room where they're taking tests gets rock music. One room gets instrumental rock music, like lyrics versus no lyrics. Sorry, that's what I was trying to say. Lyrics versus no lyrics. I would do better in the room with no lyrics, because then I tend to sing along when I'm studying or doing work. Dependent variable is the final measured variable, and so we call that the DV, or dependent variable. So in our example from the previous page, that would be the test score, the final measured thing. We want to see what their test score is. Did the music make people score lower on average on the test, or did the music not change? Did everybody score about the same on the test? Oh, are you not seeing slides right now? Sorry, Adam asks if you're supposed to be seeing slides. Is everybody not seeing slides, or is that just?
I am.
Okay, so some can see them, some cannot.
I do.
You should be seeing slides though, Adam. Sorry about that. Feel free to download. It looks like most people commenting can see them, so maybe download the slides and then you can follow along, even if they do die on the broadcast. Or you can always watch back at this section in the lecture as well. But sorry about that. I don't see anything on my end that would suggest why you individually cannot see, or why any students wouldn't be able to see the slides. Maybe try leaving the meeting and coming back, see if that fixes it. But we'll keep going on. All right, so IV is the variable the experimenter manipulates, like the noise level in a room. Dependent variable, the DV, is the final measured variable. All right, so with this, we need at least 2 groups to do an experiment. You could test, say, I've got two 10-10 classes this semester. So I could compare those 2 classes. I could say, okay, my earlier class, this is my earlier class. I've got a later class at 7 p.m. So I could do an experiment where everyone in this class gets a certain aspect of slides. Oh, good. I'm glad you can see him again, Adam. That's great. I give everybody a more distracting background, maybe. I put a moving background behind me. And then I compare test scores from your class to the other class where I have this more normal static background. So I could do that. And then I'm comparing 2 groups, but that's technically called a quasi-experiment because there might be specific reasons you students are taking an earlier class versus the other students are taking a later class, and that might be causing a difference. So students taking an earlier class might be because their work times are all late shift work times or something like that. Maybe the students taking the late class, they all have kids, and so they're taking classes after all their kids are home from school or something. So those differences might cause other differences that change their results. So the best way to get our groups to make sure we get rid of all those potential confounds, is what we call them, all those other third variables that might cause that change, is through random assignment. So to randomly assign my 2 classes to different groups, I would put a list of all the students' names, essentially. I would put every student's name in this class and the other class all together, and then I would have a computer randomly say if they're in group 1 or 2. So then maybe Marissa is in group 1, Kelly is in group 2, maybe Brianna is in group 1, and maybe Shay is in group 1 as well. And then some of the students from my other class are also in group 1. Some of my students from my other class are in group 2. So I would randomly put people in those groups. That would hopefully mix up those differences between those 2 classes well enough that I could actually determine cause. So that's kind of the idea here. We've got orange people and we've got purple people. Just orange and purple because it's different colors that are easy to see on a graphic like this. So we randomly assign and we get some orange and some purple people in the group 1. We get some orange and some purple people in group 2. And so that, the difference in the people's color, their orange or purpleness, is mixed up. So the cause of whatever result you find is not based on them being orange or purple. If you had all orange people in this group and all purple people in this group, then your cause, your change, might not be the music or the loudness in the test room. It might be because all of this was orange people and all this were purple people. Maybe purple people do better on tests. I don't know. So randomization basically reduces the likelihood that your results are coming from differences that already exist. So the group, the 230 group for Psych 1010, maybe there are specific things that might make you do better on tests already. Versus my later group, maybe they'll just tend to do worse on tests. But if I mix you all together in these 2 groups, I can get a better idea of, is it the loudness in the test room? Is that the cause? So hopefully that makes it a little more clear. With that, you might be able to see that the bigger your sample you can get and the bigger your groups, the better you're going to do about mixing up those differences. 6 people into groups of 3 is not a really good mix. But if we had, say, 600 people that we were sampling from and 300 in each group, you would hopefully kind of average out all those differences in each of those groups of 300. If you could have a sample of 6,000 and groups of 3,000, that would be even better to mix up those things. You would have people in one group that were purple, people in the other group that were purple, people in one group that had kids, people in the other group who had kids, people in one group that liked early classes, people in the other group that liked late classes, people in one group that were early birds, people in the other group who were early birds, that kind of thing. You would spread out those differences through random assignment. And that's why for a true experiment, you need to do random assignment. If I just split the two classes and compared the two, that's technically still an experiment, but it would be called a quasi-experiment because I'm not controlling all the variables. I have control of only some of the variables. So let's talk about validity. And we've touched on this quite a few times, just not with the term validity. So think about validity as being synonymous with truth or accuracy. So are the conclusions we draw from an experiment or a study sound or accurate or correct or true? So if we use the happiness face scale to test happiness, and then we had some of the participants who were using drugs and were happier because of that, is our conclusion now valid? If they were all in one group versus the other group, nobody was on drugs, would our conclusions be valid? Well, probably not. We might get some information about people who are on drugs versus not and their happiness level, but that might not be what we were originally trying to test for. So can we attribute the results to the experiment itself or something outside the experiment? If we can do a good job of randomly assigning to our two different groups, and we can have one group that's mixed up with people and the other group that's mixed up with people, and one group has music and the other group does not, we can probably do a pretty good job at concluding that the differences in test scores are because of the music. So we might have a valid conclusion there. It is possible for scientists to purposely not follow these rules like random assignment to manipulate the outcome. For sure, that is possible, but that's one reason that peer review is so important. If I was trying to submit a paper that showed, well, this is actually a good example. So I created, with some of my colleagues at Claremont Graduate University, we created a tool that should have helped young people find their purpose in life, or at least get closer to it. So with that, we did some experiments. I randomly assigned, or we as a group, we randomly assigned students to the control condition versus the treatment condition. So some got memory activities that shouldn't really affect purpose in life, and some got our fostering purpose activities. So I sent that to a peer reviewer, or I sent it to a journal, and the journal sent it out to 3 different reviewers. Usually it's 2 or 3, sometimes more, depending on the journal. And then those researchers, they read that. And so if they had seen in there that I intentionally selected people, I mean, this goes into, am I being honest in my writing of that article in the first place as well? So let's say I only picked students who were in a lot of clubs, or students who had reported on the pre-test that they were already high in purpose. If I did that to show then that they got my purpose activities and they were higher in purpose than the other group, that would hopefully be caught by the peer reviewers. So it is definitely possible for some scientists to not follow these rules and intentionally design an experiment to show their outcome of their hypothesis or that their theory is correct. So it is possible to do that. There are some systems like peer review, for example, that should catch that, as well as things like replication should catch that. So is it a perfect system? Definitely not. There's definitely been instances of things like fraud in the scientific community, both in psychology as well as in other fields, where people manipulated the experiments that they were doing to make it look like things were working out stronger or in ways that they weren't actually. People have also, it seems more common actually that a lot of people, rather than trying to manipulate a study this way, some people have just made up data. So rather than actually running an experiment, there was a professor who would say, "Oh, I will run your study to their grad students." So for their study, he would say, I'll run it with these students I'm going to be with in the next week or something. And then he would literally just make up the data. Like they found it because they looked at all his databases and they saw huge chunks of each database copied and pasted into the other databases. So he was basically just making results up as he went along. So that kind of thing does happen. Hopefully we always catch it through the systems that exist. But yep, it is definitely possible. Sorry, long answer, but definitely very good question, Shay. All right, so validity comes back to, are we actually getting results that we can attribute to our own study, or is it caused by some external factor? So if we wanted to look at someone's IQ, laying aside that IQ tests, the ones that we actually have, aren't that great, do you think that weighing someone's head on a scale would be a good assessment of their intelligence? It's fine. If I mentioned that my son just ran through the background, then probably people would notice. Yeah, so pretty obvious, right? It's kind of a silly question to even ask you. It would not be a valid result of intelligence to weigh someone's head on a scale. That's not a good way to measure intelligence. Maybe some creative problems or something, have people like solve creative problems, might be a better way. But weighing someone's head on a scale, not a great way. I'm putting my head down. It's like I have an imaginary scale by my head to weigh my head. Yeah, exactly. So if you have a big head, you're going to get a higher score. If you have a smaller head, you're going to get a smaller score. If you're a researcher who had a big head and wanted to make people seem or think you're really intelligent, you could say this was your method, and you have the highest IQ score of anyone. So there is that. There's also other things that can mess up research called bias. There can be experimenter bias as well as participant bias. So one example of experimenter bias is demand characteristics. When the experimenter, so say me as an experimenter, I accidentally tell the participants how I expect them to behave. So I've created a medicine, and I think it'll really help with everybody's headaches. It'll make all headaches go away. So when I give it to a participant, maybe I unintentionally tell them what should be happening. Maybe in the instructions of how to take it, the participant's like, oh, this should take away my headaches. And so then they get kind of maybe that placebo effect, or they report that it's taken away their headaches. Maybe the experimenter might accidentally tell people how to behave. Another one is that the experimenter's expectations might unintentionally influence the results. So if the experimenter expects things to go a certain way, they might unintentionally kind of make it go that way. And so this is different than Shay's comment earlier about purposely making things work out. They might just accidentally design something in a way, or report results, or not write down all the contrary evidence. Like they're only focusing maybe on the things that suggest it's true. They unintentionally might influence the research that way. Participants also can come, don't always, but can come to research with a bias. Maybe they know how they should act in a certain case. So they've got that information, they know they're getting this medicine, they're pretty sure that this is the right one, or the actual medicine and not a placebo. Maybe they know then that they should act more healthy or act more energized or whatever it is. So a good example of both experimenter and participant bias is actually this horse that went around doing math. His name was Clever Hans. So what Clever Hans would do is his owner essentially was kind of the researcher in this example, would have a board with different numbers or math problems or things like that. And people around would call out a number or a math equation, so 5 plus 5. And Hans, the horse, would then clop its foot. You can't really hear that. but clop his foot 10 times to say 5 plus 5 is 10. That would be embarrassing if I got that question, or like I did my math wrong right then. But so Clever Hans appeared to do math by clopping its hoof or by essentially pointing at the right column on the board. It would answer math questions, and it would generally get them correct. So, I mean, spoiler alert, the horse couldn't actually do math. So hopefully that's obvious here. So what was happening here? Why could Clever Hans get the answer right? So in this kind of case, think of experimenter and participant bias. The horse is the participant, and kind of all the people are kind of the experimenters. Any ideas on why the horse would have got the math questions right? Go for it, Kelly.
I think that the owner of the horse would actually point to the correct answer while the participants were distracted.
Yeah, so maybe something that the owner or one of the experimenters was doing was cueing the horse in, maybe intentionally even, that the owner was kind of pointing the answer out. Yeah, that's a good idea. We have some other comments on training. So trained before on how many times to tap its feet. So maybe literally learned answers to specific questions or other specific hand motions that kind of suggested to the horse of what to do. Yeah, these are good ideas. So what has actually happened, and you can actually train horses to do the same kind of trick now, is that the horse learned essentially human body language, that when it would get close to the answer, people will kind of get a little quieter, a little more tense, kind of be anxious about, well, what's going to happen when it gets to the proper number of clomps. And then when it stopped, when people's behavior was in a certain way, it got a carrot. So it got a treat when it behaved, when people around it were behaving a certain way. So it didn't actually know math, but it knew as I'm clomping my foot, if people are acting a certain way, not necessarily like actually specifically pointing at something, but when people's behavior, when the experimenters behave in this kind of way, the horse learned to behave in a certain way, to stop its clomping. So it's a really good example of both the experimenter bias and the participant bias, that the horse was coming into it not understanding math at all, but motivated to do something else, get these treats. So kind of funny. So this is one of the reasons that we use double-blind experiments. So we actually talked about them really briefly last time. A double-blind experiment is when both the experimenter and the participant don't know which group you're in. So if you're using something like a placebo, a real medicine and a placebo medicine, the researcher and the participant don't know if they are getting the real medicine or the sugar pill. So you can do a similar kind of thing with psychology experiments. I didn't use a placebo exactly in the study I described earlier of the fostering purpose activities. So I used a bunch of videos and activities and interactive things for young people to help find their purpose. The other group did a bunch of videos and activities to improve their memory and learn like memory tricks, essentially. So they didn't know which group they were in. They didn't know they were supposed to be doing better on purpose, either group. The word like purpose wasn't really, like, it wasn't talked about in that way. They were just doing these activities that should help them focus on things like their goals, things that are important to them and meaningful and beyond themselves, which are the components of purpose. I mean, definitely there were things in there that could have biased participants and suggested that this was the actual activities. But the control group, or the placebo, in my experiments, were memory activities. So they were still doing something. It was still relevant to school. So, and that's where we got most of the samples, was from high schools and college, like sampling from classrooms. So placebos are this harmless substitute treatment, and the double-blind experiment is when the participant and the researcher don't know who's getting what. So you can use all of these methods in different combinations. You can use descriptive research in your experiment. You can use correlational research in your descriptive research. You can use correlational research in your experiments to get more data and look at the problems in different ways. Your study doesn't have to be just one specific thing and one specific thing, like only looking at ice cream and violent crime. You can incorporate more variables. You can interview people as well as doing an experiment with them. So combining methods is a lot better to get a clear picture of what's going on. So with this, samples and settings. So a population is essentially everybody in an entire population. So we have the population of the world is literally everyone in the world. The population of Salt Lake Community College would be everyone who is related to Salt Lake Community College. Let's make it smaller, just say students at Salt Lake Community College. So the entire population of students is every single student at Salt Lake Community College. And our sample would be pulling from that population. So if one way I could take a sample of students at Salt Lake Community College is by looking at all psychology students, or all students in a psych class in the department. So if I did that, would that give me a clear picture of the entire population, or do you think I might be missing out on a few key students or key characteristics or attributes of students if I took only students this semester that were in a psych class? Kind of biased that and was a very leading question, but it's all right. Or what do you think would be, let's get some examples actually of a way to get a really good sample, because we've got different colored people here again for our example. So we have gray people, pink people, brown people, green people, blue people, and purple people. How could, so if we looked only at psych students, Brianna says we're missing out on students in the other schools, as well as students in a lot of, so schools at Salt Lake Community College, like people in psych might not be in business classes or engineering classes or history classes or literature or math. So we might be missing some key aspects of that. But if we wanted to get as many as we can, every aspect of the population into our sample, how do you think we could do that at Salt Lake Community College? How could we get a good sample, so a smaller group, of the entire population and try to be really representative of the population of students? What would be a good way to sample everyone? Adam suggests taking students from every single major. I think that would be a good way to try and get, not specifically to psychology, the whole population. So how would we sample from the entire population of Salt Lake Community College? Sorry, my question was unclear. So how would we get a representative sample of all the students at Salt Lake Community College? So one way we could take students from every single major. Yeah. How might we do that? How might we go about getting a student or multiple students from every single major? Yeah, Brianna's got the terminology in mind here. Random sampling of the entire student body. So we could email a survey to everybody. And some people would do it, some people wouldn't do it. We could even just on a computer of all students say, hey, send the email to every third student or something like that. So we could randomly sample in that way. We could put up surveys, like literal paper surveys around campus. Right now that wouldn't work too well because few students are on campus. But we could have the surveys around where students could pick up if they wanted to, or we could even assign students to do the survey. And hopefully we would get enough of a sample that it would be pretty representative of the population. Because we would want, if our sample had 20 gray people, we would also want about 20 pink people, about 20 brown people, about 20 green people, about 20 blue people, about 20 purple people. We'd want those kinds of differences that are systematic between people across the majors to be throughout our sample. So a lot of the students at Salt Lake Community College are within a certain age range. We'd want our sample to include people from that entire age range. We'd want people of all genders, all ethnicities, right? We would want our sample to be very representative of the population we're researching. So good ideas on how to get a good sample of Salt Lake Community College students. So a sample is that subset selected from the whole population. A random sample is one that we would be able to get at random. It would hopefully do a better job than if we just sampled psych students. We might miss some key aspects of people. We might be able to get a better a sample by randomly telling a computer, give me about 1 in every 5 students. Cluster sampling is another good example. We could sample clusters, so kind of break the whole population down into other separate groups. One of those kinds of groups could be different majors. So we say, let's pretend there are 40 majors at Salt Lake Community College. I don't actually know how many there are. But let's say there are 40. So that might be our next cluster. Again, that might not be the best cluster, but just as an example of what a cluster sample is, you would have these clusters, and then you might sample everyone from 5 of those 40 clusters, or even 15 of those 40 clusters. But in a random sample, every person in the whole population has an equal opportunity to be selected. In a cluster sample, you don't technically have an equal opportunity to be selected. So settings are also important to research. So you could do something like naturalistic observation. You're observing in a way that doesn't allow people to know you're studying them. So when you're actually in the environment with these chimps, you might change their behavior. Like this chimp here sees this researcher is there and is changing its behavior. So a better way to do naturalistic observation would be something like maybe hidden cameras around the forest, or you could do naturalistic observation of a classroom, or you could do naturalistic observation of a coffee shop, where you could just observe things without manipulating variables. So obviously in a naturalistic observation, you couldn't do an experiment within there, because then you'd be manipulating and changing behaviors. And it's hard to control for things when it is a naturalistic setting. But you could have a laboratory setting. You could make a laboratory classroom that's pretty similar to an actual classroom, but where you can control more of the variables. You could turn a normal classroom into more of a laboratory. So especially when so many students are doing things online, you could change something about the systems in Canvas or in the login systems to make some manipulations, see if we can make students do better or something by changing things. So with that, a laboratory settings does give you more control over variables, but depending on how different you make it, it might be too different and change behavior because they're in a lab. You want people to act generally as they would if you're trying to understand psychology. So one little activity that we're going to do is get into small groups. So we're going to use the small group rooms. Essentially at this point, you can choose whichever group room you want. If you get into a group room and there's already like 8 students in there, just jump to another group room. But decide on your own study. So pick some topic that you would want to study, and you're essentially just making up whatever kind of study that you would want to do. So think of your research question. What variables are you going to be looking at? So you could imagine a study of violent crime and ice cream sales, for example. You could make up a study about sports for performance and protein supplements. You could do how much water a day is related to how well you sleep. I'm just trying to think of any random thing. You could think of an experiment of vaccines and autism. Obviously, we're just doing this as a thought experiment to create our own study. So pretend you have infinite money and infinite ability to manipulate whatever you want. So if we could essentially force everybody to get such and such vaccine and then change things in their environment in certain ways, things like that. You can make it however you want. So first step, jump in a group. Second step, figure out what kind of topic you want to look at and then what variables you might look at. Think about what samples you want to pull from, what kind of ethics concerns there might be. Because even though I'm saying like you can make up your study as you would, obviously depending on what you do, it could be unethical. You could, for example, for your study, control the weather in Salt Lake City so that half of the days it's rainy and half of the days it's sunny. Like, would that be an ethical thing to do? Obviously, you don't really have that power, but in this thought experiment, you do. And talk about what methods you're doing. Are you doing surveys, experiments, interviews, everything we've talked about? So some examples for you. How do we help students learn? That's an example research question. Why do heroes act heroically? How is weather related to emotions? How is music related to emotions? Actually, I'm going to select just 2 of these because students sometimes spend a lot of time deciding. So let's talk about how is music related to emotions, or how is weather related to emotions? So those are your 2 research questions. You and your group can decide which one you do. So how is weather or how is music related to emotions? And decide on, that gives you your variables. One is emotions, but you can still decide, are you going to look only at positive emotions like happiness or more negative emotions like sadness or anger? So you still have some freedom within there to choose your variables and think about how you'll measure those. So how will you measure emotions? With hormone levels? Will you do brain scans? Will you do surveys? Will you do an experiment with the weather? Will you do an experiment with music? Or will you do something like observation? So again, your group can either choose how is weather related to emotions or how is music related to emotions. So jump in the small groups. You can choose whichever of those 9 groups that you want to be in. If there's already like 8 students in one, jump to the next one below. And we will come back to the main class meeting. I'll be jumping back and forth as you're going through it. And we'll be back here at 5, let's say 5, but I might like send a message that you have another couple minutes. And I'll keep this slide up so you can use it as reference. So be back in this general classroom at 5. Oh, and any questions before I send you off?
I have a question.
Mm-hmm.
Can you explain like a little bit more how to get in the groups? I've never used this.
Yeah, definitely.
Microsoft Teams, you know?
I did send a video before class, but it was only like an hour before class. So hopefully now you are seeing what I am seeing in the meeting. So here's where I can mute and whatnot. So all you need to do is click on the Teams link. And then after you click on the Teams link, you should see our class, and we're in general. Under the general list, there's group 1 through 9 on some different topics. So I will go to the, I'm just going to navigate to the one on happiness, and hopefully my screen recording does not cut out because I'm leaving this meeting. So you click Teams, and then you come down here to, I would go to the happiness group, group 9, and I would jump into there. And this is where I would do my meeting and other students would come and join in. We could talk about our study. You can even start your own meeting in this space, or you can do your chat. So there's an example of chatting there. So hopefully you're seeing this in the general meeting. To jump back to the general meeting, you would then just click this general meeting, or you could again click Teams and click general here and click this general meeting here. So hopefully that didn't cut out and you could see that whole thing.
Yeah, thanks for explaining.
Yeah, so jump into one of those small groups and we'll plan to be back here at 5 after your groups have come up with a study around either how weather is related to emotions or how music is related to emotions.
Or vice versa.
So if anyone is here in this main general group right now or has just recently jumped into it from the small group, most groups are needing a little bit more time. So we'll come back to this small or this main group classroom at 5:05. So stay in those small groups, finish up all the discussions there, and then we'll be back here at 5:05. All right, I'm going to hang out in here as students start filing in, and then we'll start talking about the results that you all found or the studies you all made. All right, I just tried to invite everybody that I saw still online and not in this group. So hopefully your group all decided on some good studies. Hopefully everyone's still able to hear me. Oh, it looks like my sharing screen disappeared again. All right, so let's talk about some studies that you came up with. So which group or which spokesperson thinks that they had a really good study that everybody thought of in their group? Let's get a volunteer. Looks like we had a group in group 7's room on self-determination theory, memory tips for life, and the happiness group. So go for it, Marissa.
Okay, so we didn't really get all the way through it because we were kind of like waiting for other people to join, but they didn't. So what we were thinking was with the music, the emotions related to music, we were thinking that like we could have so we didn't talk about like a specific amount of people, but like a group of people, and then have them all take a survey, like a survey to determine whether they are a more happy person or a more sad person. And then with that data, put them in different groups depending on that. And then we would have the people in the happy group, or say like more positive, not generally like happy or sad, but like more positive and more negative people is what I should have been saying. But like you would play the more like sad music to the happy people or the more positive people, and then play the more happy music to the more negative people, and then see how it affects their mood in the end.
Yeah, those are some really good ideas. So first you've got your pre-test, so where you give them the survey to check their mood, if they're generally happy or sad, and then based on that you put them into groups. So the happy people are played sad music, sad people played happy music. Did I get that right?
Yes.
All right, great. So with that, I would recommend one addition to that. So you've got this group of sad people, or people who reported sadness. One thing that would be good to compare them better is, rather than playing all of them happy music, play half of the sad group happy music and half of the sad group sad music. And then you'd be able to compare in the sad group, did those that get played the happy music, did their mood change more or less than those who got played the sad music?
Okay.
And same for the happy group. So really good thoughts, and to make it a better experiment where you could make sure that the music was the thing making the effect. Because if the happy music makes happy and sad people more happy, then it's really clear that like the happy music is doing a good job of making people happy. Same for the sad. So we're taking your 2 groups and splitting them up again, so now you have 4 groups. So yeah.
Okay, that makes sense.
Yeah, but those are some really great ideas. Any other groups that want to volunteer to talk about their experiment? Maybe a group that did the weather and emotions. I think all groups might have done the music and emotions though. But did any group do the weather and emotions? Kelly, would you mind sharing what your group decided for your experiment then?
Yeah. So our group decided to do how well studied people study with music. And so what we decided to do is our thought process is that we take a group of people and we have them study with music, of course, and then we have them scanned through an MRI and see how well they do with like certain questions in the MRI. Kelby, not Kelby, what's her name? Another group member said that we should also take the participants' blood pressure to see how well they're doing for their stress levels, also take a survey prior to know what kind of music they like as well and how well they do in like a confined space or nervousness during a test. Because there's some people are very concerned about what music they like because of the ethical things, like maybe they don't like rap, all this stuff. So we take those things all into consideration as they're studying with the music on.
Yeah, really good ideas. So it sounds like you have multiple dependent variables you're looking at, both the measures with the MRI as well as surveys. So that's a really good way to get really clear data. So first you put people into certain groups or check them before with the pretest, and then after the treatment of the music, do those same tests again, gives you a pre-test, post-test design, and that's better than just a post-test only design where you test them only after the music. So the other group was doing a similar thing. They tested them before with the survey, and then they didn't get to talking about their dependent measures at the end, but I assume it would be similar, checking their test scores or survey scores after the music, and if it made them happier or not, is what it sounded like. So really great ideas from both of the groups. So hopefully you can see some of the connections from some of the things that we've talked about today with sampling, with surveys, with correlational studies, experiments. It sounded like both of you were, both of those groups were kind of going the route of experiments then. And there's another group going the route of correlational studies. So yeah, really great job with that. I know it can be hard, especially these first weeks, to jump into these groups and start talking to each other. It's a lot harder than when you're face to face in a classroom and you can do it. It's a little more strange. And then the technology, some people have a microphone or don't have a microphone. So good job doing that and working in your groups. So I saw a comment just appear, but it's loading very slowly. I'm sorry. Okay, yeah, so the first group was going to take the survey again after listening to the music to see if their mood had changed. All right, great. So some really great methods for those studies. Hopefully that gives you a sense of what researchers do as they design a study. So with that, the next thing that we'll finish talking about is conducting ethical research. And so we've talked about some social psych studies that were maybe not so ethical, like the Milgram study or the Stanford Prison study. So let's look at this video first. Yeah, let's see if we can watch this video and learn a little bit more about ethical research and why some of the problems that started it off and why we made the rules we now have. We obviously won't watch this whole video because it's quite long, but we'll get a couple of the unethical experiments and why they were bad and what we've done now.
Studying the human mind is a tricky business. There's still so much we don't know and so many questions scientists are looking to answer. But when researchers are working with human subjects, they have to balance getting answers with protecting their subjects. In the past, they haven't always been good about taking care of the fellow human beings they're studying. A lot of historical psychology experiments would be considered unethical by today's standards, and the foundation of the ethical standards we use today comes from the 1970s, when scientists came up with a list of rules to protect the security and privacy of human volunteers. It's known as the Belmont Report. Basically, 3 key ethical principles to guide all human research. The first point is called respect for persons, and it means that subjects have to give informed consent. Anyone who participates in human research, including psychological research, needs to know the risks and benefits of the experiment before signing up. The second ethical principle is called beneficence, and it basically means that researchers should try not to have any negative impact on the well-being of the people who participate in their studies. Basically, do no harm. The final point, justice, involves making sure that subjects aren't exploited. Researchers should also make sure that the burdens of the study and the benefits of the results are distributed fairly. In early research studies, for example, the subjects would often be poor, while wealthier patients would benefit from the results of the experiment, and that's not okay. These rules apply to human research in all fields, including psychology, but the code of conduct hasn't always been so clearly defined, and before it was, there were a lot of questionable studies being done. In the year 1920, a psychologist named John Watson wanted to show that humans can be classically conditioned, like what happened to Pavlov's dogs. Basically, classical conditioning means pairing a stimulus, like food, that triggers a physical response, like drooling, with an unrelated stimulus, like a bell. Even though ringing a bell, of course, wouldn't normally make dogs drool, when Pavlov paired the sound with food, he conditioned the dogs to respond to the bell by drooling. Watson and his team decided to prove that this could be done in humans by classically conditioning a 9-month-old baby named Albert using animals and scary noises. First, the researchers presented Albert with a fuzzy white rat. As he'd reach out to pet the animal, the psychologists would strike a hammer against a metal bar behind his head, creating a loud noise to startle him. Eventually, just the sight of the white rat was enough to make Albert start crying and crawl away. He'd begun to associate the fear of the loud, scary noise with the fuzzy white rat. So yeah, Albert had been conditioned, but this study failed in a lot of ways. For one thing, it used a single subject and no controls, so Watson hadn't really proved anything. But then, of course, there were the ethical issues. Watson never reconditioned Albert to not be afraid anymore, so he was permanently affected by the experiment and not in a good way. We also don't know if Albert's mother fully consented to the research, which definitely violates the main ethical principles of the Belmont Report. And this wasn't the only horrifying psychology experiment conducted on children in the early 20th century. In the late 1930s, a psychologist named Wendell Johnson and his graduate student.
So there's some other great examples in this video, but I think that one example hopefully gets you a good sense of some of the unethical studies that we've done. We also talked about the Milgram study where people thought that they were shocking other participants. There are other examples in medical research of treating participants really poorly, intentionally infecting people with syphilis, for example. And so around the same time as those medical studies were being done, these unethical psychology studies were being done. And people, a lot of people said, well, we should stop doing these kind of terrible things to human participants. So the Belmont Report happened, and we also, now the American Psychology Association, created their own ethical guidelines, kind of in addition to this Belmont Report. So all research institutions in the US that receive any kind of federal funding for whatever field, so even if their federal funding is for something in chemistry, they will still have an IRB that even the psychology professors have to go through. And the IRB is an institutional review board. Essentially, when I want to do my study, or when you want to do your music study, you would send the IRB for Salt Lake Community College your study. You would propose it. They usually have forms to fill out, and you describe your study. And you say, well, these are the participants I want to access. This is why I want to study these people. This is exactly what they're going to be doing. This is how I'm going to keep them safe, make sure it's fair, make sure it's ethical. And then the IRB will come back to you and say, hey, good job with X, Y, and Z, but you're not being safe enough with their data. So that's an example of something that I had to revise with one of my study plans is I had to make sure that the data from participants was stored anonymously and stored in an encrypted file. So a little change for me, but this is what the IRB does. If I was doing something that could potentially harm the people, they would have caught that and they would have said, hey, you can't do that. Let's change your study so that you can do a more ethical study. So the other equivalent organizations exist in many countries. The IRB is a US focused institution. But the main things that all of these institutions are having people get is that informed consent. So not just consent that, yes, I will do the study, but letting people know what's going to happen in the study. You might not tell them absolutely everything if you need to do some kind of manipulation, but as much as you can, and especially any risks that they're under. Confidentiality, make sure all their data is confidential. You wouldn't publish it in identifiable ways without their permission. A debrief is a really important thing that was missing in the experiment. A debriefing is telling the experimenter or the participants in the end what the study was actually about, what you learned, making sure they leave with no bad feelings. So making sure little Albert is no longer terrified of white things, making sure that people don't feel bad about the scores on the happiness survey they got. Make sure they have contact information for the researcher and that they are leaving with good feelings about the field in general. Try not to use deception is a big thing too. A lot of social psych studies tried to use a lot of deception originally. But yeah, the deception is something you don't want to use. So we're out of time for today, and we're out of time on chapter 1. There's only a couple more slides on ethical research in this chapter, so definitely go over them on your own time. Make sure you've read the chapter. Don't forget to turn in your chapter 1 smart book because that's due tonight at midnight. So hopefully you have finished the chapter already. So we will see you again on next Tuesday when we'll be covering chapter 2. So are there any questions? I mean, if there aren't any questions, feel free to leave right now. But if you do have questions, feel free to stay and I'll answer any questions right now too. So thank you all for coming today. I'll be around if there's any questions for the next couple minutes.
Thank you.
Thank you. Bye.